See next last problem D. D is nothing but f of x is equal to modulus of x minus 5. We know modulus means that is nothing but plus or minus value. So whatever we can take, that is plus or minus 5. So which is nothing but here, if x minus 5 only. So x minus 5 when we will get here, if x is greater than or equal to 5. Okay. Minus of x minus 5. Minus of x minus 5 when we will get means if x is less than 5 is there means then we will get here x is minus value will get here. This function is. So here total we have to do total 3 cases we will get here. Here also we are taking here let a be any real number. Okay. If it is any real number we are taking here. So what is the case 1 here? Case 1 is if a is less than 5 we are taking. So less than 5 you will take here. So what will get here? F of k is f of a is equal to 5 will get here. Less than 5 means minus of x minus 5. So which is nothing but 5 minus a will get here. Next, limit x tends to a, f of x is equal to limit x tends to a, f of x is nothing but x minus 5. Sorry, this one less than 5 now. Minus of x minus 5 will get, this is nothing but 5 minus x will get, which is equal to 5 minus x. So 5 minus x is nothing but 5 minus a here. Therefore, limit x tends to a, f of x is equal to f of a here, which is nothing but 5 minus a. Okay. So therefore, f is continuous. At a less than 5. Okay. Next, case 2. Case 2 is we are taking exactly a is equal to 5. If a is equal to 5 means we'll get exactly same x minus 5 only will get here. Therefore, f of x is equal to x minus 5, which is nothing but f of a is equal to a minus 5 only will get here. So a minus 5, even limit function also limit extends to a, f of x is equal to a minus 5 only. So both are equal means f is continuous. X is equal to a or x equal to 5 here. Okay. Next, case 3 is we are taking here less than over equal to over next greater than. If a is greater than 5 here. So a is greater than 5 means therefore f of x is equal to greater than 5 also will take here x minus 5 here. So f of a is equal to a minus 5 comma limit x tends to a plus f of x here. Also a minus 5 will get here. So this one also we are getting a minus 5. This one also a minus 5 only getting means therefore f is continuous at x is equal to 5 that is greater than x equal to a greater than 5. Okay. So this function is less than function also it is continuous only, equal to also it is continuous only, greater than 5 also it is continuous only. So therefore f is continuous at every real number. F is continuous at every real number. Okay. The next one. So prove that the function f of x is equal to x to the power n is continuous at x equal to n, where n is a positive integer here. See here, given that f of x is equal to x to the power n here. So at x equal to n we are taking. So at x is equal to n, if we will take f of n will be n to the power n only will get here. Okay. Next also limit function if we will take limit x tends to n f of x. So limit x tends to n. F of x is x to the power n is equal to, in place of x if you substitute n to the power n only will get here. Therefore, so both are same means limit x tends to n, f of x is equal to f of n, which is nothing but n to the power n we are getting here. Therefore, f is continuous at x is equal to n, where n is positive integer. Okay. The next one, fifth one is the function f is defined by f of x equal to x if x is less than or equal to 1 and 5 if x is greater than 1 is continuous at x equal to 0, at x equal to 1, at x equal to 2. So whether it is continuous or not, we have to check here for all these numbers here. See, given that f of x is equal to x if x is less than or equal to 1, 5 if x is greater than 1 here. So first we are taking at x equal to 0. At x equal to 0, the function will be limit x tends to 0, f of x is equal to limit x tends to 0. Limit x tends to 0 means 0 will be less than 1. So 0 if we will take less than 1 means the function we have to take here x. So in place of x if we substitute 0, we are getting here 0 only. Okay. Therefore, even f of 0 also if you will take, so 0 if you substitute is nothing but 0 only will get here. Therefore, f is discontinuous at x equal to 0 here. This function is discontinuous. Okay. The second one is at x equal to 1 we are taking here. So at x equal to 1 means we have to take here LHL, RHL and f of the function also we have to take here. So what about LHL function? First we'll take at x equal to 1 is nothing but f of 1 is equal to 1 only will get here. Next LHL is, so limit x tends to 1 minus f of x is equal to, so f of x is limit x tends to 1 minus f of x is x only, which is nothing but 1 we will get here. Next RHL. RHL is limit x tends to 1 plus f of x is equal to limit x tends to 1 plus f of x is, so 1 plus means greater than 1 we will get here 5, which is nothing but 5 will get here. So LHL is not equal to RHL. So therefore LHL is not equal to RHL. Therefore f is not continuous at x equal to 1 here. Okay. Sorry, f is not continuous at x equal to 1, but in the 0 if it is continuous only. Why? Because at the 0 if you will take here less than 1, this function we are getting 0 on 0. So f is continuous function at 0 at x equal to 0. But at x equal to 1, this function is not continuous. Next, greater than 1 is nothing but 2 we are taking here. At x is equal to 2 here. At x equal to 2, f of 2 is equal to greater than 2 if you will take, that is value is 5. Next, greater than 5, limit function if you will take, x is equal to 2 at f of x. So limit x tends to 2. F of x is 5 only. So this is nothing but 5 only. Therefore, limit x tends to 2, f of x is equal to f of 2 is equal to 5 we are getting. Therefore, f is continuous function. F is continuous at x is equal to 5 here. So here the less than 1, so 0 is less than 1 means of that function, this function is continuous only. Even 2 means this is greater than 1, that's why this function is continuous only. But at x equal to 1 only, this function is not continuous. So this function is continuous at every number, every real number except 1 here. Okay.